Hi everyone. Today we are going to see about the general introduction about signals and system and what are the basic elementary signals used in signals and system and what are the different types of signal. Signal is defined as a function of one or more variable which conveys the information on the nature. Our signals are represented mathematically as a function of one or more independent variable varies with respect to time. Sine wave, cosine wave, triangular wave, ECG and EEG signals are the best examples of signals. Based on the dimensional, signal can be classified into three types: one-dimensional signal, two-dimensional signal, and multi-dimensional signal. When the function depends upon a single variable, then the signal is said to be one-dimensional. Example, speech signal. When the function is depends upon two variable, then the signal is said to be two-dimensional. Example, image. When the function is depend upon two or more variable, then the signal is said to be multi-dimensional signal. Example 3D image. And then let us see about the system. System is a device or combination of device which can operate on signals and produces corresponding response. Every system has one or more input is called excitation and every system has one or more output is called response. Input and output of the system are always signals. Example communication systems. Some elementary signals are used in signals and system. These signals are used to solve more complex problem. So the signals are unit step function, unit impulse function, unit ramp function, parabolic function, signum function and exponential function. So unit step function, it can be denoted as u of t. The amplitude of u of t is always equal to 1 except t value less than 0. And then unit impulse function, it can be represented as del of t. It has 0 amplitude except at the time t value equal to 0. And then unit ramp function, it can be denoted as r of t. The amplitude increases linearly at the proportion of time period. Unit parabolic function. Mathematically, it can be represented as t square by 2 for t value greater than equal to 0. When t value less than 0, the amplitude of the signal is 0. And signum function, when t value greater than 0, the amplitude is 1. When t value less than 0, the amplitude of the signal is minus 1. When t value equal to 0, it produces the amplitude 0. An exponential signal, it can be represented as x of t equal to capital A into e power at. Here, capital A equal to amplitude of the given continuous time signal. Based on the exponential value A, it can be classified into growing exponential and decaying exponential. Based on the nature, the signal can be classified into continuous time signal and discrete time signal. Continuous time signal, the amplitude value continuous with respect to time, and we can define the amplitude at all instant of time. It can be represented by x of t. And discrete time signal whose amplitude is not continuous with respect to time. We can define the amplitude at particular instant of time, that is called as discrete time signal. It can be denoted by x of f. And continuous time and discrete time signal can be classified into periodic and aperiodic signal, even and odd signal, energy and power signal, deterministic and non-deterministic signal, stationary and non-stationary signal. A signal is said to be periodic if and only if it satisfies the condition x of t equal to x of small t plus capital T. Here, capital T equal to fundamental period. It can be calculated by 2 pi divided by omega. Here, omega is the angular frequency of the given signal. If it not satisfies the condition, the signal is said to be aperiodic signal. An aperiodic signal does not repeat after a specific interval of time. Even and odd signal. The signal x of t is said to be even signal if it satisfies the condition x of t equal to x of minus t. Even signal is also called as symmetric signal. Odd signal. The signal is said to be odd signal if it satisfies the condition x of t equal to minus of x of minus t. Odd signal is also called as antisymmetric signal. Energy and power signal. Energy signal is one in which has finite energy and zero average power. The energy of the given continuous time signal is calculated by integration of minus t2 plus t magnitude of x of t the whole square into dt. And power signal is one in which has finite average power and infinite energy. The power signal can be calculated by 1 by 2t. The limits varies from minus t to plus t magnitude of x of t the whole square into dt. A signal cannot be both energy and power simultaneously. Also, a signal may be neither energy nor power signal. Power of energy signal always zero and energy of power signal is always infinite. Deterministic and non-deterministic signal. Deterministic signal can be predicted and completely specified in time. Sine wave, cosine wave, triangular, rectangular waves are the best examples for deterministic signal. We can predict the future amplitude. Non-deterministic signal which cannot be predicted and random value at any instant of time. Example, noise signal and ECG signals are the best examples of non-deterministic signal. Stationary and non-stationary signal. The signal characteristics does not change with respect to time is called as stationary signal. The signal characteristics change with respect to time is called as non-stationary signal. So these are the some of the signals used in signals and system. Next, let us see about what are the basic operations performed on signal. Basic operations which mainly depends upon amplitude and time period. Based on the amplitude scaling, addition, subtraction and multiplication are performed on the signals. Based on the time period, time shifting, time scaling and time reversal are performed over the signal. Amplitude scaling is nothing but the amplitude scale signal y of t is expressed in terms of the following signal x of t. Mathematically, it can be represented as y of t equal to capital A into x of t. Here, capital A equal to amplitude scaling factor. For discrete time signal, it can be represented as y of n equal to capital A into x of n. Next, let us see about addition, subtraction and multiplication. Consider two input signal x1 of t and x2 of t. The addition of two signal can be represented as y of t equal to x1 of t plus x2 of t. Here, the amplitude of two input signals are added. In subtraction, the amplitude of x2 of t is subtracted from x1 of t. Output is stored in y of t. In multiplication, the amplitude of x1 of t and x2 of t are multiplied and the result is stored in y of t. Next, let us see about what are the basic operations performed with time, that is time shifting, time scaling and time reversal. Time shifting operation which mainly depends upon time period. The signal x of t may be shifted in time by replacing the independent variable t by t minus t naught, where t naught is the time shifted variable. The output signal y of t for time shifting operation can be written as y of t equal to x of t plus or minus t naught. Based on the t naught value, the waveform is shifted right side or left side. T naught value positive, the waveform is shifted to the right side. T naught value negative, the waveform is shifted to the left side. Time scaling operation, it can be represented as y of t equal to x of at. Based on the a value, the signal is compressed or expanded version. When a value greater than 1, the signal is compressed version. When a value less than 1, the signal is expanded version. Time reversal or reflection of a signal can be denoted as y of t equal to x of minus t. x of minus t is the time reversal of the given signal x of t. Even signal is the positive reflected signal and odd signal is the negative reflected signal. So these are the basic operations performed on the signals. Thank you.